Welcome to solverfy.
Okay, in this problem we have a laser with a known wavelength of 585 nanometers, a power of 20 watts, a pulse duration of 0.45 milliseconds, and a diameter of its beam of 5 times 10 to the negative 3 meters. We were asked to find A, the energy per photon, B, the area of our laser beam, and C, the number of photons per area being emitted. So the only equations we'll need the energy of a photon, hc over lambda. We need to know that the total energy of a pulse is power times duration, time, and of course the area, assuming that our beam is some cross-sectional area of our beam is a circle, we have pi d over 2 squared. Okay, so let's jump into it, solve. So starting off, we'll get the energy of a photon, which is simply hc over lambda. We know lambda, we know h, we know everything. We end up, let's get the result in EV, 6.626, e to the negative 34 joule seconds times, let's divide by, we're going to divide by 1.6 e to the negative 19 joules per EV. We're going to take our 585 e to the negative 9 meters and the speed of light, 3 times 10 to the 8 meters per second. Plugging all these numbers in gives us a energy of 2.12 electron volts per photon. Good. So next, let's get this area of our beam, assuming it's circular. Pi 5e to the negative 3 meters divided by 2 squared. This would give us a result. Well, actually, we can keep it in millimeters. The answer, they want the answer in millimeters, so let's do that. So this will end up just simply being 2.5 millimeters. And we are left with 19.63 square millimeters. Okay, now for this last part, to determine the number of photons per area, we need to first determine how many photons are in our beam, which means we need to determine the total energy of that beam. So the total energy of our beam is simply the power times the time duration, P delta T. So 20 watts is 20 joules per second, times our delta T is 0.45 e to the negative 3 seconds, giving us a result of 0.009 joules. Let's get this in the electron volts. So once again, we can divide by 1.6 e to the 19. This gives us our total energy in electron volts. Now, to determine the number of photons, we can simply divide the total energy by the energy per photon. We know both of these things, so 5.6 E16 electron volts divided by 2 electron volts per photon. We're going to be left with a lot of photons. 2.65 times 10 to the 16 photons. So that's a lot. So to get the photons per area, we can simply take this number. So I guess pho over area. Actually, it's n over area. So n over area, you can take two numbers you already know. The 2.65 times 10 to the 16 divided by the area we found to be 19.63 square millimeters. we are left with 1.35 times 10 to the 15, 5 photons per millimeter. Per square millimeter, I should say. And that's it. That's what we were asked to find. Okay, great.